Welcome back, everyone. Today's explainer is diving into something that is fundamentally shifting how we think about AI infrastructure. We spend so much time watching AI agents do things, but today we're going to look at exactly where they do those things. We are exploring a completely new infrastructure layer. Honestly, it's an entirely new paradigm called Agent Native OS. So if you're building agent frameworks, contributing to open source AI, or you're just really fascinated by the future of autonomous systems, this explainer is going to completely rewire how you look at agent environments. Let's get into it. To kick things off, I want you to ask yourself a pretty fundamental systems question. What kind of operating system does an agent actually need for its own work? Because right now, we are answering this question completely the wrong way. The entire industry is currently obsessed with teaching AI to use human computers. We want them to move our mouse, click our icons, read our screens. But here's the thing, AI agents aren't humans, and building systems that force them to act like humans is actually holding them back. All right, section 1, the trap of human tools. Let's look at why adapting graphical user interfaces and human environments is actually failing our agents. When we take a hard look at our current approach, the unintended consequences become glaringly obvious. We kind of just assume that giving agents more human tools makes them smarter, right? But look at what actually happens. When we give an agent a web browser, we get what's called context overflow. Imagine forcing a person to read through thousands of raw HTML code just to find a single submit button. It's like having 100 browser tabs open all at once. It rapidly eats up memory. When we give them open terminals and APIs, we get source pollution and role bleeding, which is where the agent loses track of what data it's supposed to use and literally forgets what its actual job is. We try to string all this together with workflow automation or file editing, and we just end up with broken handoffs, unaudited outputs, and long-run degradation. The ultimate result here? Massive token waste across really messy, fragile workflows that become incredibly hard to govern. And this brilliantly illustrates the core problem. There's a fundamental disconnect between what humans need and what agents need. On the last side here, the human OS manages applications, visual windows, background processes, and mouse clicks. That's built for us. But an agent OS? It shouldn't care about a desktop wallpaper or where a visual window is positioned on a screen. It needs to manage context, carefully mounted sources, isolated tasks, output contracts, and audit gates. It needs to handle handoffs and recovery natively. It is an entirely different set of first-class citizens. Moving right along to Section 2, a native computer for agents. This is where we need a massive shift in our mental model. Before we define exactly what Agent Native OS is, we need to clear up some technical misconceptions right out of the gate. First, Agent Native OS is absolutely not a Python project. Yes, there are some small Python scripts in the repository, but those are literally just reference helpers for demo validation and workspace checks. Second, it is not a prompt collection. Third, it is definitely not a GUI automation tool. And finally, it is not a desktop environment. So if you're picturing an AI moving a cursor around a screen, just erase that from your mind entirely. Instead, Agent Native OS is a spec-first, natural language-first operating system architecture, and it's designed specifically for long-running, large model agents. To put it clearly, Agent Native OS is the Windows layer for AI agents. It provides a native operating layer, a governed workspace where an agent can install targeted skill apps, securely mount data sources, execute clearly defined task cards, follow output contracts, generate handoff reports, pass audit gates, and crucially, recover from failure without human intervention. I really want to pause here and let this philosophical shift sink in. Contracted natural language is source code. Think about it. Traditional software was built around machine code, right? Compiled instructions for silicon processors. But agent-native systems are fundamentally different. For a large language model, natural language is the computing instruction. Therefore, the core of Agent-Native OS isn't written in C++ or Python. It's written in Markdown, YAML, and structured contracts. It treats contracted natural language with the exact same rigor that traditional programming treats machine code. Okay, Section 3, the 5 core principles. Let's explore the rigorous foundation that makes this system work. Let's break down these mechanics. First up, context is the first-class resource. In an agent OS, managing context is basically like managing RAM in a traditional computer. Second, as we just touched on, contracted natural language is source code. Third, the context kernel is the actual runtime environment where these natural language instructions get processed. Fourth, structured output is the context ABI, meaning it sets the strict rules for how data moves in and out of the agent, acting as the application binary interface. And fifth, skill apps are installable applications. This completely shifts the paradigm. You aren't writing complex backend scripts just to string messy prompts together anymore. You're configuring a workspace using YAML and Markdown where the agent fundamentally understands its boundaries. Next up, Section 4, the governed operating loop. Let's see how these principles actually function in practice. In the repository, there's a validation demo called the docs brief demo. Now, it's super easy to glance at this and think, oh, okay, it's just asking an AI to summarize some text. But that misses the point entirely. This demo proves that agent work can be strictly permissioned, scoped, and contract-bound. It's a proof of concept for a minimal governed operating loop, completely replacing that standard, messy chat interface developers usually rely on. Let's walk through how this builds into a precise step-by-step flow. Step 1 is the source mount. The agent doesn't just get access to your whole hard drive, it gets an isolated mount of the exact data it needs, nothing more. Next, the task card defines the specific scope of work, so there's zero role bleeding. Then, the output contract sets strict rules for what the agent is actually allowed to return. Step 4 is the agent run inside the context kernel. After that, we get the handoff report, which perfectly prepares the state for whatever agent or system comes next. And finally, the audit gate. This acts as a strict check to validate that the output matched the contract. This precise, governed flow is exactly how you prevent context overflow and unaudited outputs from ruining your system. Finally, Section 5, the future of AI workspaces. Let's zoom out and look at the macro impact of all this. So, what does this all mean? Why does this matter beyond just being a really fascinating open source infrastructure project? I want you to think about what happens to the industry when we adopt a universally governed workspace instead of the chaotic, messy prompt workflows everyone is just kind of building from scratch today. The macro impact here is absolutely huge. First, it directly reduces massive token waste because the context is tightly targeted and governed. Second, because of those audit gates and output contracts, long-running AI workflows actually become reliable. They don't just degrade over time. Third, developers can stop reinventing the wheel. Instead of rebuilding messy prompt workflows from scratch, they can build standardized, reusable skill apps. Plus, because state is handed off so cleanly, this lays the actual groundwork for true multi-agent collaboration. And, looking to the future, this spec-first architecture sets the foundational standards for intelligent robot operating environments. Ultimately, we aren't just building better tools for agents. We are defining the very workspace where agents can actually work efficiently, securely, and natively. So I'll leave you with this final powerful thought from the project's core philosophy. Stop teaching agents only to use human desktops. Give them a native workspace. When we finally stop treating agents like human interns and start treating them like native compute engines, what will you build? Thank you so much for joining me for this explainer. Keep exploring, keep building, and I'll catch you in the next one.